Suzanne Bird here, the Ute Lake Online Learning Center. Algebra 1, Semester 1, Unit 2, Lesson 6, Solving Equations by Multiplying and Dividing, which is also considered one-step equations. In this lesson, though, they're going to combine Lesson 5 with Lesson 6 towards the end. So really we're looking at one-step evolving into two-step equations. Okay, let's get started. Okay, so in the last lesson I talked about doing the reverse order of operations, and we undid math operations by doing opposites. And so this time we're going to be multiplying and dividing, undoing multiplying and dividing. Okay, so let's look at this first equation. Okay, there's no plus sign, there's no minus sign. All right, there's just numbers and letters. Okay, when you got a number and a letter next to each other, that means multiplication. Okay? So, we want to, in order to solve the equation, solve for x, we want to know what x is. Yes, we can do the mental math. Again, we know what x has to be. 10 times what is 40. We know the x is 4. But let's follow the steps, because when things get more complicated, we need to make sure that we're following the steps to keep things straight. So, since 10 is being multiplied to x, we need to undo multiplication. Undoing multiplication means dividing. All right, or opposite of multiplication is dividing. Now then, I'm going to draw like a fraction bar. A fraction bar means division. All right, so when I draw this bar right here, this means I'm dividing. And I'm going to divide by the number that's next to the 10. So I'm going to divide by 10. Okay, now 10 divided by 10 is 1. All right, so I could write this as 1x. That's what's left. All right, I don't have to, and I'll talk about that in a minute. So again, remember our seesaw little example that I talked about in the last lesson. We need to keep these guys level. In order to do that, whatever we do to one side, we have to do the same exact thing to the other side. So I divided this side by 10. I need to divide this side by 10 too. All right, and so when I divide 40 by 10, I get 4. Okay, I wrote the 1 to let you know that 10 divided by 10 is not 0. A lot of times when you just students, when they get into this, they say it's 0. It's not 0, because if it was 0, anything times 0 would make x 0, and then we've got a problem, because this is not true. All right, so I illustrated that this is the 1. Okay, and let me just go ahead and go through the motions here. 1 is being multiplied by x, right? So whatever x is, the 1 doesn't affect it. So I can write the 1, or I can, most likely I'm just not going to write the 1. 1, like I said in the last lesson, it likes to be invisible. It's its special power. It's one of its many special powers, but the main special power of 1 is it likes to be invisible. All right, in the last lesson, we, instead of writing a 0, we crossed out the things that went away. And even though this turned into a 1, it essentially went away. So we can just cross out the 10 there and just write the x. Okay? And then again, I can always plug in this value in for here and double check. So 10 times 4 is 40, check. All right, that's how I check. Okay, let's look at another one. So here we go. And again, it doesn't matter what the letter is. This is a B. And it doesn't matter about signs. Other than you have to mathematically make sure your sign, your answers are right. So I'm looking at this, and 14 is being multiplied to B. To undo the multiplication to get B by itself, to isolate B, I have to do opposite. Opposite of multiplication is division. So I multiply that side by 14. I have to multiply this side by 14. This goes away because it equals 1. I'm left with 1b. and then I do math here. Now remember, don't take these negatives for granted. Don't drop your negatives, okay? Use a calculator if you must. A negative divided by a positive is a negative, and this is going to be -4. All right? Okay, so that's multiplication. Let's see, I think I got another one. Again, sometimes equations are given to us with the variable on the other side, like this. If you need to, you can rewrite it. You can rewrite it like that. If that is more comfortable, it doesn't matter. The answer is going to be the same. Just make sure your negatives are where your negatives need to be. Okay, right here we've got a -7 multiplied to the n. Okay, there's no plus or minus sign in between here, so there's no adding or subtracting going on. It's just a -7 being multiplied to n. So the opposite of the opposite of multiplying is dividing. So we're going to divide by a -7, and we're going to divide by this side by -7. Remember that when something's a negative, that's like a porcupine quill stuck in your nose. All right? You're not going to just yank that puppy out. You're going to have someone else help you out, hopefully numb it a little bit. So until that happens, wherever you go, that porcupine quill goes. So don't drop your negatives, because you'll get your answers wrong. So -7 divided by -7 is a +1, which is what we want. We don't want a negative, because we still have an issue with that. All right, so divide by the exact same thing that's going on there. It goes away. N is left over here, and then 21 divided by -7 is -3. Voila. Okay, let's look at some division. All right, division looks like fractions. I think I'll skip that one. Yeah, division looks like fractions. Okay, there's the days of having this little symbol right here are gone, long gone. All right, now we write everything as fractions, because fractions is really dividing things. All right, so this guy right here, the little fraction bar, means division. Okay, so V is being divided by 8. So to undo division, I have to multiply. Now then, for the sake, to help keep things squared away, well, that's not really the right terminology. Let me just show you. So I'm going to multiply this side by 8/1. Okay, this is a fraction. I need to set this up as a fraction so that I don't get confused and accidentally, I can show it like that, which is totally fine. But sometimes what happens is people forget, and they end up multiplying this 8 and that 8 together, and then you haven't done anything but make it a bigger problem. So I like to, at the beginning, when you see a division, multiply by a fraction like that, okay, with the denominator as the numerator, because we know that this is basically saying 8 divided by 8, or 8/1 times 1/8, and the 8's cancel out, or if you're not good with fractions, that would be 8/8, which is 1. Okay, so that's essentially what I'm doing. I'm showing with that. I probably will forget sometimes to put it over 1, but that's what's going on, and these cancel out. Okay, these cancel out when I do that. On this side, I don't have to show the fraction. Okay, I can just show the 8. All right, I hope I didn't confuse you on that one. We'll do a few more. Okay, let me just, okay. Okay, so I want to get x by itself. X is being divided, so I need to do opposite of division. So I'm going to multiply this side by the reciprocal, so to speak. The reciprocal, or the upside down version, whatever you want to call it, that helps you remember. Okay, so these guys cancel out. Over here, I don't have to write that 1. If I do, it's no big deal. Okay, the 1 just goes away anyway. And so x equals 8. Okay. If you get used to this, if this is confusing, then just when you multiply, show that number up above. Or just out here. Just remember that you're multiplying to get rid of it. Okay? So I don't know. You're not here to tell me which one you prefer. I may end up doing, I probably will revert back to doing this. I just want you to realize what's going on. Okay? Alright, let's see. Let's look at this one with the variable on the other side. Again, you can rewrite it, opposite, mirror image it if you need to, but it's the same method. I need to know what x is. So x is being divided by 11. So I'm going to multiply by both sides by 11. These cancel out. And so x equals 66. Okay. Let's do one more. Just because of the negatives, no big deal. Just remember when we're multiplying, we multiply the negative. X is being divided by 18. To undo division, I need to multiply by 18. Okay? I need to multiply this side by 18. And a positive and a negative make a negative. Okay. Again, I can always check. I can go back and say, well, it's x divided by 18, so x is 90, negative 90, divided by 18. What does that equal? Well, it does equal negative 5. So that's how I would check that. Okay, let's move on to some of the problems you will see in your lesson. Okay, and in your lesson, they kind of made it where you looked at it twice. No big deal. Here's one of the problems, or an example of one of the problems you'll see. Okay. Two things are going on here, right? We're dividing by 5 and we're multiplying by 2. Okay? I can look at this as a fraction. Let me show you this in 2 different ways. Whoops. Okay, one way to look at it as this is a fraction, and I would multiply the reciprocal, or the upside down version of the fraction to both sides. Okay, if I did that, see how the 5's cross out and the 2's cross out, and I'm just left with x. That means that I need to multiply the other side by their reciprocal. If I do that, I can make this a fraction by putting 1 over it. And I can cross cancel, or I can just do fraction math, however, whatever is more comfortable. Multiply the numerators, multiply the denominators, and then simplify. 20 divided by 2 is 10. Okay? Or I can look at it as 2 steps. I can see that, well, the first thing I want to do is get rid of the fraction. Okay? To get rid of the fraction, I've got to get rid of this 5. 2x is being divided by 5. So to get rid of the 5, I've got to do opposites. I've got to multiply by 5 on both sides. So there goes the 5. 5's gone. The only thing left on this side is the 2x. And now this side is 20. And then, now I've got another one. 2 is being multiplied to x. So to undo multiplication, I divide. So I'm going to divide by 2 here, divide by 2 here. These 2 goes away. These 2's go away. And I'm left with x and 10. Okay? So if fractions scare you, don't do this. Do this, get rid of the fraction immediately. Okay? If fractions are your friend, go for it. Okay? Either way, you're going to come up with the right answer. It's okay. Let's, yeah, I don't think you'd want to do that. I definitely think that you would want to get rid of the fraction before you would get rid of the 2. Otherwise, you were just going to make a bigger fraction. Okay, it's not going to change anything. You'll get the right answer. I just wouldn't recommend it. And so I'm not even going to show it. Okay, here's another one where we combine lesson 5 with lesson 6, where we have both things going on. The very, very, very important thing is that you add or subtract first. Okay? We talked about the order of operations and how we do the opposite, and adding and subtracting is the last thing you do when you're using order of operations, so it's the first thing you do when you're trying to isolate the variable. Okay, if I try to divide by 5, it's going to get complicated because what the heck do I do with this 2? Do I divide by 5? What do I do? And that's where our mistakes get made, and it just gets really, really unnecessarily complicated if I try to do division or multiplication first. So I'm always, always, always going to get rid of any adding or subtracting first. So I look at my negative 5x as one big glob of x. I don't worry about that 5 right now. And what I see is that something is being added to it. So in order to get this big glob of algebra by itself, I need to get rid of anything added or subtracted by doing opposites. So my first step is I'm going to get rid of adding and subtracting. So I'm going to do opposites to both sides. All right, remember this goes away. This goes to 0. So then I can drop down what's left, my glob of algebra, and 12 minus 2 is 10. Okay? Then I'm going to multiply or divide. Okay, so we always add and subtract first, and then we multiply and divide second. Always, always, always. It's so much more easier. Otherwise, it's just, I really don't recommend. I mean, you could do it, but it would just, you have to be really good with fractions, and so just don't. All right, so negative 5 is being multiplied to x. So to undo multiplication, I have to divide. Divide by negative 5. Divide by negative 5, both sides. Keep everything equal. This goes away. And x equals negative 2. Because a positive divided by a negative is a negative. Okay, let's look at one more. I think one more. Oh, crud. Yeah, no, I want to look at another one. They throw another one at you before you're ready. Okay, so let's look at this one. 4x minus 8 equals 16. What am I going to do first? I got to get rid of anything added or subtracted first. Okay? So 8 is being subtracted from this glob of algebra. So I want to add 8 to get rid of it. Add 8. So I'm basically moving 8 over there. So I'm left with 4x equals 2, 3, 8 is 21, right? 8, 24. Okay, now I have all that's left is multiplication. So I need to undo multiplication by doing opposites. Opposite of multiplication is division. Divide both sides by that 4. This 4 goes away over here. Okay, and I'm left with x. 24 divided by 4, 6. Voila. Okay, so adding and subtracting first, then multiplying, dividing. Okay, you're probably going to be doing most, I'll say it, and then I'll be wrong, but a lot of your algebraic equations are going to look like this, and so you're going to end up dividing. And you always, even when they get more complicated, you're always going to be dividing last. Always, always. Okay, so let me show you something that they threw at you that if as a teacher, I would disagree with until I taught it. But well, that's okay. We're going to persevere. We can do it. Okay. All right, now we've got parentheses, dang it. That just throws a whole loop in the system. Or does it? Okay. I have a feeling that one of the next lessons we're going to talk about distributive property. I know probably earlier in this unit they probably defined distributive property. I think I did a video and I remember talking about distributive property, whether you watched it or not, that's your prerogative. But when you have a number, or well, it could be a letter too, but when you have something on the outside of parentheses like this, okay, and you don't see a plus or a minus right here, it's just this number is next to. This means that this guy is being multiplied to everything in here. Now, if x was just a number, we could just do the math in here, right? If x was 3, we would do 3 minus 1, and then we know that we would multiply to 6. But we're trying to get x by itself, and we've got this mess here. So before we even add and subtract, so this is where your order of operations kind of jumps around. Before we add and subtract, because I told you have to add and subtract first before you multiply and divide, you have to get rid of parentheses. Get rid of them. I wish I could just erase them. Okay? How do you get rid of them? You use the distributive property. What does that mean? It means deal those cards by multiplication. We're dealing with multiplication. Hopefully that's still on the camera. So what that means is we're going to take this 6. Let me change colors here. We're going to take this 6 and we're going to multiply it to the x. Okay? So 6 times x, well, I don't know what x is. That's just 6x. And then we're going to take the 6, we're dealing the 6 to the x, we're dealing the 6 to the 1. We're going to do this 6 times the 1. All right? 6 times 1 is 1. This minus sign goes along for the ride. We just drop down that minus sign and we do 6 times 1. 6. And then we rewrite the rest of the equation. Okay, so now we've got an equation that doesn't have parentheses. We got rid of the parentheses first. Okay? Now then, the other thing is we've got x's on both sides. Okay? And so in lesson 5 I talked about before you start isolating, you need to get everybody on one side. All right? We need to have a family reunion of x's over on the left side. How do we do that? Well, we got to do opposites. Okay. This 2x is in front of the 10, right? It's 2x plus 10. So my instinct is to subtract, which your instinct would be right. Okay. Another way of looking at it is just look at the 2x by itself. There's no negative there, so this automatically means that it's positive. All right? It's an automatic positive. So think of positive. What's opposite of positive is subtract, or negative, which is same thing as subtracting. So I want to subtract or add a negative, however you want to look at it. Okay? So I really stress this because right now, yeah, it makes sense. But later when they get complicated, a little bit more complicated, we lose sight. Or if this happened to already be a negative, oh my gosh. So just think of the sign. Look at the sign in front of it. If there's no sign, it's automatically a positive, and so I'm going to subtract, always. And remember, I line my x's up with my x's. I'm not going to subtract 2x from 6 because I can't do it. That 6 doesn't have an x. It would be illegal math. Whatever. You would get the wrong answer. Don't even do that. Just line your x's up with your x's. Okay? So 2 minus 2 is 0, so this glob goes away. 6 minus 2 is 4, so now we're left with 4x. We didn't mess with anything else. All right, this plus just goes away, and it becomes a positive 10. Okay? All right, so let's see. I said get rid of parentheses first, and then this is called collecting like terms, combining like terms. I don't know. I'll just say combine. Combine and collect. Like terms. And they're like because they both have x's. All right. So here's my thing. Now I have to add and subtract because we always do that before we multiply and divide. So this 6 is being subtracted from this glob of algebra. So we're going to add the x. Add the x. This goes away. I'm left with just 4x over here, and that equals 16. And then finally, like I said, about 9 times out of 10 or 9.5 times out of 10, whatever, you are always going to end up dividing last. So 4 is being multiplied to x, so I'm going to undo that by dividing, and I divide on both sides, and x equals 4. Okay, so they kind of threw a lot at you right here, and maybe they're just hoping that you are really good at it, which is, I hope you are too. You were intuitive. But in case you weren't intuitive, this is, I mean, we're just, the next lesson down the road, this is what's going to happen. So if you have parentheses, you're going to get rid of them first by distributing them, which means you deal what's on the outside to the inside with multiplication. Okay? If you've got globs of x's or globs of algebra on both sides of the equal sign, you need to get them all in one place. I highly recommend going left 9 times out of 10. Okay? Once you do that, then you're always going to get rid of adding and subtracting. And then finally, you're going to get rid of multiplying or dividing to get your answer. Okay? So that is that. I hope that helps you with those lessons. Okay? And then I will start looking at the next lessons. I think there's a quiz after this one. And I'll start looking further down the road and see what's happening. I hope this was helpful. Talk to you later.